Welcome back to another deep dive.
Good to be here.
We're plugging in today to a really fascinating corner of the AI world. It's something that's kind of bubbling right under the surface, but it could have massive implications for where all this tech goes next.
Yeah, absolutely. We're surrounded by AI now, aren't we? Generating text, images, code. It's everywhere.
Totally. And these models are learning, they're generating. But the big question we're tackling is, what happens when these AIs start learning from each other?
Mm.
When the data they train on isn't just human-made stuff anymore, but AI-made.
It sounds like a cycle that could get, well, problematic, right? Like a sort of digital echo chamber getting weaker each time.
Exactly. And that's the core idea we're unpacking today. Model collapse.
Yeah.
It's a really interesting, maybe, slightly unsettling phenomenon happening behind the scenes.
And we're basing this on some great sources you shared, deep research from Nature, some really insightful articles from the Register, LinkedIn too.
Right. So our mission here is pretty clear. Let's get to the bottom of it. What is model collapse?
Yeah.
Why is it happening?
What are we actually seeing now in the real world? And crucially, is there anything we can, do about it?
Think of it like trying to figure out what happens when the digital world starts feeding on itself, recursively.
Okay.
Let's dive in. So let's kick off with the basics. What exactly is model collapse?
Okay, so at its simplest, it's what you get when AI models are trained on data that was itself generated by other AI models.
Right.
So instead of learning from that original, messy, diverse, human-created data, they start learning from, well, synthetic versions of reality, copies, essentially.
Okay. That LinkedIn article had a fantastic analogy for this.
Mm-hmm.
Imagine a top chef, right? Michelin star. Always gets the freshest stuff from the market.
Uh-huh.
But one day, they decide, I'll just reheat last week's leftovers.
Mm-hmm.
And they try to make new dishes only from those leftovers.
Okay, I see where this is going.
And then the next day, they use the leftovers from that meal. What happens to the food quality over time?
Yeah, it degrades fast. You lose the original, the freshness, the nuance, the connection to the source, really.
Exactly. And another classic analogy, mentioned in the sources, is the old photocopy of a photocopy idea.
Oh, yeah, that one's perfect.
Each copy adds tiny flaws, loses a bit of detail, and eventually the picture's just this blurry, distorted mess. Doesn't look much like the original at all.
And in the AI world, that's the model starting to kind of misperceive reality.
And researchers, they've come up with some pretty vivid names for this, haven't they? Beyond just model collapse.
Oh, yeah, you hear things like AI inbreeding, AI cannibalism, even Habsburg AI.
Habsburg AI, I like that one. A nod to the genetic issues from royal intermarriage.
Right. And there was another one, model autophagy disorder, or MAD for short.
MAD. They all paint this picture of the system kind of consuming itself or collapsing inwards.
Definitely. And the Nature paper, which really gets into the weeds on the theory, it identifies two main stages in this degradation process.
Okay, what are they?
So first up, you have early model collapse. This is where the AI starts losing information about the less common things, the tails of the data distribution, as they call it.
The tails.
Mm.
So like the outliers. The stuff that doesn't happen very often in the original human data.
Exactly. The low probability events.
And the Wikipedia source mentioned this can be tricky to spot initially, right? Because the overall performance might seem okay.
Yeah, that's a key point. It might look fine on the surface, but it's already starting to disproportionately forget or misrepresent that less frequent data. Minority data, sometimes.
Okay, so that's early collapse. What's next?
Then you get to late model collapse. And this is where things get, well, much more severe. The model's output starts converging, narrowing down.
So it looks less and less like the original data.
Right. The variety, the diversity of what it produces gets massively reduced.
Huh.
And in the really extreme cases, the model can become super confident about just a tiny range of outputs. Basically, it collapses down to maybe just one best guess for everything.
Wow.
Researchers sometimes call that a delta function.
So like the chef who can now only make, I don't know, mashed potatoes.
Huh.
Or the photocopy that's just a solid gray square.
Pretty much.
But why? Why does this happen? What's the actual mechanism driving this digital decay?
Well, the Nature paper does a really good job breaking this down. They pinpoint three main sources of error that basically pile up over generations of training on this synthetic data.
Okay.
The big one they identify is called statistical approximation error.
Statistical approximation.
Yeah.
Yeah, okay. What's that in, like, normal terms?
It just means that whenever you sample data for training, even from the original source, you're only ever using a limited number of
Yeah.
examples, right? A finite sample.
Sure.
Now, when you sample from data that was already generated by a previous AI, which was itself just a statistical approximation, you're inherently even less likely to capture those rare events, those tails we talked about.
Okay, so each generation makes it worse.
Exactly. Over generations of sampling from increasingly synthetic, possibly degraded data, that information about the less common stuff just gets diluted. It fades away. Eventually, it's forgotten.
It's like trying to describe the entire Amazon rainforest,
Yeah.
but you've only ever seen one small patch near the visitor center.
That's a great way to put it. You miss all the rare species, the unique little ecosystems out there.
Got it. So that's one error source. What else?
The second one is functional expressivity error. This is about the model itself. Any AI model, like a neural network, it has limits. It has a certain size, a specific architecture.
Right.
It's never going to be a perfect mirror of the true, incredibly complex data distribution of the real world. It can't capture everything perfectly. There are limits to the patterns it can even represent.
So even if you gave it perfect data, the model itself has limitations.
Precisely. It can only ever approximate reality.
Okay. And the third error?
That's functional approximation error. And this one's more about the training process itself, how the algorithms we use to teach the model, like stochastic gradient descent, actually operate. They have their own built-in limitations and approximations too.
And the key insight here is that these three aren't separate problems. They interact.
Exactly right. They don't just sit there in isolation. These errors feed off each other. They cascade. An inaccuracy introduced at one stage makes the errors worse in the next generation, and so on.
So the total error just keeps growing.
Significantly with each round of training on AI-generated data.
The theoretical models they talk about in Nature and Wikipedia, they seem to really drive this home. They show how, say, with simple discrete distributions, these sampling errors basically guarantee that the tails vanish and eventually everything collapses to maybe just one state.
Yeah, and they show similar things with other models, like approximations using Gaussian distributions. Training on synthetic data makes the model's understanding drift further and further from the original truth.
They mentioned a way to measure that drift.
Right. Researchers use metrics like the Wasserstein-2 distance. It essentially quantifies how far apart two probability distributions are.
So how far the AI's learned reality is from the actual data.
Exactly. And in this case, that distance tends to grow as models train on synthetic data, and the model's variance, its ability to produce diverse outputs, collapses towards zero.
It's quite striking, isn't it, how these, seemingly very technical mathematical ideas point towards this being almost an inevitable result of this recursive training.
Yeah, it's not just a maybe this could happen. The math suggests it's kind of baked into the process, if you're not careful.
Okay, so the theory is pretty compelling. A bit worrying, maybe. But are we actually seeing this collapse happening out there in the real world right now?
Well, according to the sources, yes. Nature and Wikipedia both point out that this isn't just a problem for the huge language models we hear about all the time.
Well, really?
Yeah, model collapse has been observed across different kinds of generative models, even simpler ones like Gaussian mixture models or variational autoencoders, GMMs, VAEs.
But I guess the focus is heavily on LLMs just because they're so widespread now.
Understandably, yeah.
Yeah.
And the Nature paper shared details from an experiment where they took some relatively smaller LLMs, OPT 125 meter models specifically, and they fine-tuned them on data generated by earlier versions of themselves.
Okay, so a direct test of the recursive training idea. What happened?
The results were pretty clear. They saw performance go down. They measured it using perplexity. That's basically how surprised the model is by new, unseen data. A higher number means it's less confident, performing worse.
And did they see that convergence thing, the collapsing towards certain outputs?
Yes. They found the model started producing text that was very similar to what the original model really liked. So, yeah, collapsing towards its preferred modes, its favorite ways of saying things.
But didn't they also find something else? Like it started making new kinds of mistakes?
That's right. They also found the model started producing things the original model would never have said. These much longer tails of output. Basically, weird, nonsensical, or just plain wrong stuff started appearing, which reflects that accumulation of errors.
If you look at the actual text examples they put in the Nature paper, it really shows it. You can see the generated text getting more repetitive generation by generation, losing coherence, just getting, well, strange.
Yeah, and that ties into another finding they mentioned, the ablation repetitions bit. Repetitive phrases are apparently a really common feature in AI-generated text anyway,
Uh-huh.
and their study found that even if you try to specifically penalize the model for being repetitive, it still doesn't stop the underlying model collapse. And sometimes trying to fix the repetition actually made the overall performance even worse.
Wow. So it's a deeper problem than just repeating phrases.
Seems so. And maybe the most tangible evidence for you listening comes from those real world examples in the LinkedIn article.
Right, tell us about those.
Well, think about AI art models. If they're trained mostly on other AI generated images, you start seeing those telltale signs, the monstrosities as the article called them.
You mean like weird hands, strange proportions?
Exactly, bizarre anatomy, features that just look off because the model's internal understanding of what things should look like has degraded from reality.
Or what about the media platform AI, the one that started making up news?
Yeah, that was another one. It started inventing fictional news stories, apparently, after being fed AI-written summaries of actual news. The input quality dropped, and the output went off the rails.
And the corporate chatbot one, that's almost comical, but also kind of alarming.
Oh, definitely. The chatbot trained on internal company documents, but some of those documents were apparently AI-generated themselves.
Oh,
And it started hallucinating HR policies, telling employees to submit vacation requests using Slack emojis or something equally bizarre.
okay, maybe not that funny if it actually happened.
Right. These aren't just tiny glitches. They're models confidently spitting out fundamentally wrong information because their view of reality, learned from the data, has become corrupted.
Which brings us neatly to the kind of the really big picture consequence here,
Yeah.
this idea of data pollution.
Yes. And the Register article used a brilliant analogy for this. Absolutely brilliant. It compares this flood of AI-generated data online to, get this, nuclear test fallout contaminating metals.
Wow, okay. Explain that.
So, before the atomic age, steel produced before nuclear testing started was free from certain radioactive isotopes. It was clean. That low background steel is now super valuable, essential for sensitive scientific instruments.
Because modern steel is slightly contaminated.
Exactly. And the argument is that the explosion of generative AI tools, especially since, say, late 2022, when things like ChatGPT became widely available, has unleashed this massive wave of AI-generated content online.
Contaminating the data pools for future AI.
That's the fear. It risks polluting the very information that the next generation of AI models will need to learn from. So data created before late 2022, human-generated data, is becoming the digital equivalent of that low background steel.
Increasingly valuable.
Increasingly valuable, and the sources really hammer this point home. Having access to genuine, original, human-generated data is becoming absolutely vital and maybe increasingly scarce for sustaining high-quality AI development.
And the potential consequences sound quite significant. It's not just about polluting the training data itself.
No, there's the potential loss of the AI's ability to model those low probability events we talked about. The tails.
Which matters why.
Well, that's not just a technical detail. It affects how well models can capture the full diversity, the full nuance of the real world. Think about fairness issues, understanding marginalized groups, or modeling complex systems where rare black swan events are important. If the model forgets the tails, it can't do that well.
Okay. And the register also flagged a market risk.
Yeah, a potential market concentration risk. Think about it. Companies that already have massive proprietary archives of clean, pre-AI human data.
Like social media platforms
Mhm.
or huge digital libraries.
Exactly. They might suddenly have a huge competitive advantage. It could become much harder for startups or new players to train really good, robust models if they can't get access to this increasingly precious, clean data.
And Maurice Kyoto made an interesting point in the register, too, about usability.
Right. He said the risk isn't just that the models become unreliable liars, but that they might stop producing anything usable at all. Even if usable sometimes means confidently making things up, like that HR chatbot.
An AI confidently hallucinating policies could cause real chaos.
For sure. And there's also this very real concern about potentially irreversible contamination. If AI content becomes so widespread online that we can't effectively filter it out.
Then finding genuinely human data for future training becomes incredibly hard, maybe impossible.
Or at least prohibitively expensive. Yeah, that's the worry.
So, wow. Is this model collapse just Inevitable? Is the digital world basically doomed to keep eating its own tail until everything's just mush?
Well, there is some debate. The Wikipedia article mentions that some researchers argue it might not be quite so catastrophic.
Oh.
Their argument is that synthetic data is likely to accumulate alongside a continuing stream of new human-generated data. They see that as more realistic than synthetic data completely taking over.
So maybe a mix is manageable.
Perhaps. But regardless of, the exact severity or timeline, the sources all seem to agree that we need to think about action, about potential solutions, though none of them are easy fixes.
Okay, what sort of things are being proposed?
Well, one obvious area is preserving and making sure we maintain access to original human data, that low background steal.
Makes sense.
What else? Another big area is developing better ways to actually tell the difference between AI-generated data and human data.
How would you do that?
Things like provenance tracking, basically knowing where data came from, digital watermarking maybe, or building AI detectors.
Yeah. But the register sounded a bit skeptical about those.
Yeah, they were cautious, pointing out how hard it is to implement this stuff reliably at internet scale, and also how easy it can be sometimes to just remove watermarks.
Tricky.
The Nature papers suggested maybe we need some community-wide coordination, AI developers, deployers actually working together to share info and figure out these data provenance challenges collectively.
What about policies? Government stepping in?
That's definitely being debated. You hear ideas like mandatory labeling of AI content.
Which sounds hard to enforce globally.
Extremely. Other ideas involve promoting techniques like federated learning. That's where models train on data locally, like on your device, without the raw data itself being copied and centralized. That could reduce the risk of contamination spreading.
But there's disagreement on whether governments should intervene.
Yes. The Register touched on that debate. There's the risk of acting too late, letting the market concentrate around those companies with the big clean data stores, but also risks with premature or poorly designed regulation. It's complex.
Okay, so for you listening, navigating this space, maybe you need to understand this for your job or you're just trying to keep up. The LinkedIn article had some practical takeaways.
Absolutely. It really stressed being sort of obsessive about data provenance. If you're dealing with an AI system, ask questions. Where did its training data come from? If you can find out.
Good point. And keep humans involved.
Crucial. Keep human input in the loop. Don't just blindly trust AI outputs, especially if they might somehow feed back into future training or decisions. Review things, validate them.
And fundamentally break that recursive loop. All right.
Yes. Don't automatically feed AI-generated output straight back into training data sets without really strong checks and balances. Make sure you're not poisoning your own well.
Monitor for drift, too, I suppose.
Definitely. Keep an eye on the quality, the diversity, the general nature of an AI's output. Look for signs that it might be degrading or starting to collapse.
Okay, so let's try and pull this all together from the sources we've looked at. Model collapse seems like a real thing.
Yeah. Theoretically grounded, observed in practice.
Yeah.
It happens when AI models learn from data generated by other AIs, and they degrade over time.
And it poses a threat to the quality, the reliability, and maybe even the future development of AI systems because it pollutes the data supply.
Right. Which means access to genuine human-created data that digital low-background steal is becoming incredibly important, increasingly valuable, maybe increasingly scarce.
So understanding this stuff isn't just for AI researchers, is it? It helps you, listening, to evaluate the AI tools you might use.
Yeah, to anticipate the risks, like factual errors popping up, or maybe noticing a loss of creativity or diversity in the output.
And it really underscores why the source and the quality of data are just paramount in this whole AI era.
Absolutely.
The problem of model collapse, it seems like it goes beyond just accuracy today. It raises questions about whether future AIs will even be able to properly model the true complexity and diversity of our world. Could this widespread data pollution fundamentally cap the potential of AI down the road in ways that might be really hard, maybe even impossible to fix?
That's the big provocative question, isn't it?
It really is. It's a powerful reminder, I think, that even with all this incredibly sophisticated AI, the messy, diverse, sometimes unpredictable nature of genuine human reality, human creativity, that remains the essential, irreplaceable foundation.